And here in this class, we want to look at this topic, circle geometry. And first thing we should understand when we talk about circle geometry is circle. We need to understand what circle is. Definition of a circle. A circle can be described as locus of a point, locus of points, which is equidistant from a fixed point. So this is what a circle is. Now we have a fixed point. Let's call it point, and then with equal distance. So this distance might be any distance. It's 3 centimeter, 4 centimeter, and this locus of a point moving with equal distance on this fixed point now is what is referred to as a circle. So it's moving with equal distance in the sense that from the center of the circle to any part of this point, it has the same distance. And this distance here is referred to as radius of a circle. So that's the definition of a circle. And also, we need to identify some parts of a circle. So when we have a circle like this, let's draw a circle again with a center hole of a circle. Now, the first thing that I want to identify here is radius. That is, before we can start solving problem on circle geometry, we need to understand some part of the circle. Number one, radius. The radius is a line that is drawn from the center of the circle to any part of the circumference, just like we have it. So we can draw from the center to the circumference this way. So this line drawn is a radius. Okay, so it might be in any direction. You might draw it this way or that way. Now the second one we want to see here is diameter. A diameter is a line that is drawn passing through the center and touching the circumference at both sides. So like it passed through the center, touch the circumference of this side, also touch the circumference of this side. That is, don't forget this is also a radius. Have it that way. And if we draw this one now like this, so it is also a radius from the center to this place is also a radius, which means radius plus radius, that's 2 radius, give us a diameter. So this line here is now a diameter. That is a line passing through the center and touching the circumference of both sides. So we can say diameter is now equals to 2 radius. Diameter equals to 2r. Okay, that is that. Then next, also, we should be able to recognize what they call a sector. Before a sector, let's look at what a chord is. A chord is just a line. This is a line that is drawn touching the circumference at both sides. Any way we draw it, so it's touching the circumference at both sides. So if I draw a line here touching this circumference at this side and at this side, this line is called a chord. So you might draw it in any way. So that's a chord. A line touching the circumference at both sides is a chord. You might draw it this way. It doesn't really matter how it is drawn. So this is also a chord. Okay. Then when we look at something here, we discover that diameter also touches the circumference at both sides. So diameter is also a chord. which is a special chord. That is the longest chord of a circle. Okay? The longest chord of any circle, that's the diameter. And number 4, let's consider what is called an arc. Okay? An arc is a part of the circumference. We can cut any part of the circumference, and that will be an arc. For instance, when we cut from here to here now, from this place to this place, if we cut it, it's looking like this. So this is what they call an arc of a circle. So a part of the circumference cut is what is called an arc. So that is that. And also, we need to identify what is called a sector. A sector is a region bounded by two radii and an arc. Two radii. Let's look at it here. We have a radius, making two radii. Then an arc. This region, which is bounded by this, which is going to be shaded now. This region here now is what is called a sector, a region bounded by two radii and an arc. So we have these two radii, this is a radius, and bounded by this arc. So a region bounded by two radii and an arc. So this region here is called sector. We call that sector of a circle. And the next one, which we are going to do, before we look at the next one, here we have sector. And the one shaded there is a sector. The other part not shaded as well is a sector. For instance, this is what I'm saying. This is the way I have it here. We have this as center, and we have this as radius, and this side is shaded this way. So this side shaded here is a sector. Okay, this one not shaded as well is a sector, in the sense that here we have an arc from here to here. Let's label it as A, B, C. We have an arc AB, and we also have an arc ACB. So this arc ACB is a big arc here, which is called a major arc. So this is a major arc here now. Why this AB is just a minor arc? So in the sense that, yeah, this sector shaded, we can call it minor. So we have what is called a minor sector. I also have what is called major sector. So this not one not shaded is a major sector. That is a bigger one. Okay. Now next, we still have something called segment. A segment is a region surrounded by a chord and an arc. Now here we have a chord, and from here to here we have an arc. So this region here, shaded, is what is called a segment. So we have this region as a segment, a region surrounded by a chord and an arc. So we call it a segment. Okay, and also the one that's not shaded up here is also a segment. That is a bigger one, which is now the major segment. Here we have the minor segment here. So these are the part of the circle we first need to be able to identify before we move to the theorem. Now, before we move to the first theorem here, there are some things we need to know, as we can call it lemma, that is the prerequisite before the major theorem. Then, first one, we should understand that a chord, subtends two angles at the center of a circle. That is, when we have a circle with center hole, then we are given a chord. Let's consider this as a chord AB. Then this chord subtend two angles at the center. The word subtend here, the same thing as the word formed. So when an angle is formed by a line, it means the line of the angle is coming from these 2 points. So here we can connect A to O here and also connect B to O. So which implies that this chord AB has formed this angle at the center. And here we have two angles at the center now. We have this one inside here, which is an angle less than 180. That's obtuse angle. And we also have the one outside here, the exterior angle, which is reflex angle here. So angle greater than 180. Now, for this now, it's very important we are able to recognize when a chord forms angle at the center of a circle. And we have two angles there, one inside and one outside. So we can say that one angle, interior angle AOB, the center. Also, we have reflex angle AOB at the center. So the one outside is reflex angle. That is the first thing we need to establish here. And the second one as well, also a chord or an arc. As this case as well, it's also not just a chord, but also might be an arc. A chord or an arc. In the sense that if it is not a chord given, we can clean this line. And AB here now will now be standing as an arc. I believe that's taken. So if a chord is not mentioned and is an arc, we just take the arc from here to here as arc AB. So arc AB can also angle at the center, which is two angles. So, but in this case now we are making use of a chord, all right? So we have a chord or an arc subtends, also subtends two angles at the circumference. At the circumference of a circle. So when we talk about all these words we are saying here, we are already familiar with it. We know what a chord is or an arc. We know what the meaning of the word subtend. Subtend means to fold, all right? And we know what circumference is. Circumference is distance around the circle. Now, when we have it in the diagram like this, we can see what we're talking about. We have a circle with center hole, and yeah, let's make use of a chord. So we have this chord, we call it chord AB. Then this chord here subtends two angles as circumference. Now, first, it can form one at the major segment because this chord here has divided a circle into two segments. We have the minor segment here and the major segment here, right? And this chord now form this angle here at the major segments. So when an angle is formed, the leg is coming from both points A and B. So we have this angle, we can call it C up here, which is now we have angle ACB. Remember, when we are naming angle, we should know how to label angle using 3 letters. That is, this is the angle we are talking about, and is in between line AC and line BC. So C is the middle. So C is the major point or the major letter that will be at the middle. So we are going to pass from A to C, then from C to B. That's why we have A, C, B. So we are going from A to C, then to B. So we know how to label angle with 3 letters. All right. And also form another angle here, which is at the circumference as well. You know, this is the circumference here at this side. This is also a circumference at this side. So we can call this angle D. Also, we have angle ADB. That is moving from A to D, then to B at the circumference. So these are the 2 angles that is formed at the circumference. So these 2 points are very important. And you know, when we talk about diameter is also a chord, right? Which also can subtend angle at the circumference. And that's a theorem on its own. So when we have a center of a circle and you have a line passing through the center here, we discover that this line we draw now, we can label it as AB. This line is a diameter because it's passing through the center of this circle. Then the angle subtended by this diameter at the circumference, it might be at any side, maybe up or down, it doesn't matter. Once it is angle formed at the circumference, now let's form it this way. It's coming here, and when we label this as C, this angle ACB here will be right angle. So it's that theorem says that angle in a semicircle is right angle. So that is the short form of that theorem. Angle in a semicircle. You know, a diameter, we divide a circle into 2 equal parts. That makes it a semicircle. So that's why angle in a semicircle is angle 90 degrees. And we might also say that angle subtended by diameter at the circumference is 90 degrees. So these are the first prerequisites for us to know before we look at a theorem, the theorem properly. So well, let's look at the first theorem, which will become first in this class. So we can label it as theorem 1. Theorem 1 here, the theorem states that the angle subtended, the angle subtended by a chord or an arc at the center of a circle is twice that which it subtended, that which it's subtended at the circumference of the circle. So we have some keywords here which we need to identify. When we're talking about this now as theorem 1, we need to identify some keywords here. Is that the angle subtended by a chord? Yes, we are going to have a chord. Actually, we want to talk about a chord or an arc without first talking about a circle. So circle is very important, and the angle is obtained by this chord at the center. So this is a keyword at the center of a circle is twice. So we have a major keyword here, twice. So that angle at the center is double. When you say twice, another word for twice is double, is twice that which it subtended. It, yes, is referring to the chord or an arc. That which is subtended at the circumference of the circle. So this is another keyword. Now, to prove that theorem here, we can start by saying the first thing is that what are we given? Given. So this is how to state theorem. First, we should be given a circle center hole. So it's in the theorem already, so that's why we stated it as given. Then two, we are given a chord. Let's use a chord here. You might use an arc as well. Chord AB. Let's use a chord AB, but it's better as we are stating it, we are demonstrating it in a diagram. All right. So we can draw the diagram here to demonstrate this. A circle center hole. So we have this center as this. Then a chord AB. We can draw the chord this way, anyhow we want it. So we draw a chord. Just make sure it's a chord, touching the circumference at both sides. And also, on the question, we are given some things as well. Angle at the center. So we can say angle AOB at the center. Now, we are going to have two angles at the center, but in this case now, we want to consider the interior angle. So we connect A to O and also B to O. So we have this angle now formed at the center here. Also, we have angle at the circumference. So we can say we have angle ACB at the circumference. So here we are going to have this angle at this side here. So this is for the first category of the diagram. We have ACB at the circumference. And if I want to draw the second diagram for this, don't forget that since we have two angles at the center, we can say that we also have this diagram here. And this is the center of the circle here. Oh, we have this chord AB here. And we join A to O and to B. And we have this angle at the center here now. And here, the angle at the center is the reflex angle here. Then the way we are going to draw the circumference is going to be the other way around. So the circumference will be at this side. Now, something important is here. So if the angle at the center is the interior angle here, the angle at circumference will be at the upper part of this circle. But if it is the reflex angle here, it will be at the other side here. So we can leave it like that. Now, what are we to prove? Now, required. What is required of us to prove here in this theorem? To prove that angle AOB is twice. Look at it, it's twice. Angle AOB here means angle at the center. Now, is twice means two times angle at the circumference. Is twice the angle at the circumference. Angle at the circumference here is ACB. So 2 times angle ACB. So that's what we have to prove. Then we can go to the proof proper now. Before the proof, there's something called construction. So let's construction here. You can join C to O and extend to a point D. That is, this is what we are saying. We join this point C and point O with a line, construction line, and we can extend it to a point D. Okay, now, proof now. The proof, from what we have here, we can consider triangle AOC. So from triangle AOC, look at that triangle here. We have AOC. We have this line AO to be coming from the center to the circumference, and we call that radius, right? Also line CO, also coming from the center to the circumference, also radius, which means that line AO is equals to line CO. So let's clean this first and use just one diagram here. So this line are the same now. Why are they the same? Radius, radii of same circle. Okay, so that's the reason why. Then, which implies that triangle AOC now is an isosceles triangle. So that's why our elementary geometry is also important. Why is it an isosceles triangle? Because once you have two angles, two sides equal in any triangle, like you have it this way, you have this triangle, and they said this side is equal to this side. This mark here indicate that this side is equal to this side. This triangle now is called isosceles triangle. And in an isosceles triangle, once two sides are equal, as in this case, the third side here is the base, and the base angle here are also equal, which implies that here, since this is the base, the angle here and the angle here should be equal. That is, we can now say that the angle we mark now, we can call it angle CAO. Angle CAO is now equals to angle ACO. Angle ACO, we can now call it a letter. Since they are equal, let's use X. We can say this is X, this is X. So we call it X here. Why? Because they are base angle of isosceles triangle. Base angle of isosceles triangle. That's the reason why. And also here, it's very important to know some things here. When a triangle is extended, like for instance, we have a triangle, the way we have it here, one side is extended this way. That is, one side is elongated, extended. This is exterior angle, and we call this angle as X, this angle as X. This exterior angle now will now be sum of the two opposite interior angle. That is X plus X here, which will be 2X. So we apply that same thing here. This side is extended. Exterior angle here now is the sum of the two opposite triangles. So here also will be 2x. So we can establish that here. That is this angle here, which is angle AOD. And here angle AOD is equals to x plus x, which is 2x. Why is it like that? Exterior angle of triangle AOC. That is that. Now we are done with this side. Now let's similarly, also we have same thing. You can say similarly, triangle BOC. Triangle BOC. As this is triangle BOC is an isosceles triangle as well. Why? Because we have line BO is equals to line CO. Both are radii. BO here is a radius. CO here is also a radius. So both are radii, which make this triangle BOC now an isosceles triangle. And in the same way, we have the base angle here. This is a base. Also, this is a base. The base angle also equal. We can call this a letter Y. This is also be a letter Y. Okay? So that's what we are written now, which is angle BCO. That is angle BCO is now equals to angle CBO. Angle CBO, we call it letter Y. All right. And also, the exterior angle of that triangle, which is this angle, this triangle is extended, it's going to be the sum of the two opposite interior angles. So we call this 2y. All right. So that is also there, angle BOD. Angle BOD is also equals to 2y. That's exterior angle. Okay. Now, conclusion now. Where we are going, we want to find the angle at the center. The entire angle at the center, which is angle AOB. This angle here, AOB, is now same thing as 2x plus 2y. We agree? Because we have 2x here, 2y here. So when we add everything together, that gives us 2x plus 2y. And here, we can factor 2 out, and we have 2 into brackets x plus y. All right. But here, we should note that angle at the circumference here is also everything here like this. We have x plus y. So that is, note that angle ACB, the one we mark now is ACB. ACB is also equals to x plus y. That's angle at circumference. That is, instead of writing this x plus y, we can just simply write angle ACB. That is, here, conclusion now we say angle AOB is now equals to 2 times x plus y, which is angle ACB. That is, we have proved the theorem from the required. What we have in the required has now been proved. So that's the proof of theorem 1. And once we can prove this theorem 1, all other theorem follows. So all other theorems follows on theorem 1. We will also have called theorem 2, which the proof follows from this theorem 1. Theorem 3, also the proof of that theorem follows from theorem 1, and so on and so forth. So if you are joining us for the first time, why don't you give us your support and subscribe? And by also sharing this video so that it will reach out to some other viewers out there. So stay tuned as we go live again. We continue from the next theorem. We are going to build on this from here. And do have a wonderful day. And bye for now.